Good morning, good afternoon, everybody, and welcome to another of our interviews, 10 Minutes With, which lasts 10 minutes. My name is Iain Gillott from iGR, and these interviews are with leaders from the wireless, mobile, and digital infrastructure industry. So today, we're joined by LaChance, who is co-founder and CEO of ZenFi Networks. And as you can see, I've known Ray for a while. As you can see, Ray's sitting there floating above Manhattan. It looks like he's in his home office. So today we're going to talk about what ZenFi does and get into some of the specific questions as well. So Ray, the first question is the easy one, of course, is who are you and what do you do?
Great. Well, thanks for having me, and I appreciate the opportunity. As you said, I'm a CEO and co-founder of a company, ZenFi Networks. We're a communications infrastructure provider of fiber optic network, distributed data center, and wireless siting solutions, primarily focused on the mobile operators' outdoor small cell deployments. We started this company a little over 6 years ago, and we had a mission, and the mission was to build a new type of fiber company that was purpose-built to support the requirements of mobile densification throughout our region. And over the past 6 years, we've built about 1,100 miles of fiber. And part of that fiber is called front haul fiber, which is very different than the traditional backhaul fiber networks that have built in the past. We recognized that the old networks wouldn't work to support the new problem. And we got into this business with a laser focus on creating high capacity, highly accessible networks that supported fragmentation, that small cell deployments. And you can imagine in a city like New York, where you put a small cell or multiple small cells on every single street corner, the old networks just wouldn't work the way they were built. So we began that business focusing on that space.
So are your customers exclusively the mobile operators, or is it enterprise operators? Is it a mix? How do we break it?
Well, that's interesting because the mobile operators are our primary customers, but we do have some very interesting opportunities with, we have a big opportunity with one of the web scale providers where we have literally thousands of nodes on the streets in New York that are supported with our fiber network. That same infrastructure we call a CRAN infrastructure is built in a way to support mobile edge devices, whether they're small cells, Wi-Fi access points, radio heads, DAS remotes. It's the same infrastructure that CRAN infrastructure supports it. We also, because we're a fiber provider and we've built a pervasive, very dense network throughout the region, it's backwards compatible. So we can do backhaul, and we have an enterprise network overlay business. So we take advantage of this network that we have just about everywhere in our region. And we do offer carrier, wholesale, and enterprise offerings, typically through partners and third parties that leverage our fiber to build their value-added.
Yeah, we've done a couple of these interviews with edge compute providers. So the fact that you're connecting to them with the fiber ties it all nicely together.
Sure.
So final question, then we'll move on. You mentioned the region. What region do you cover? And I think there's a big clue in the background there.
Yeah, look, we started ZenFi, the focus initially specifically on New York City and the densification opportunity there. Obviously, the biggest market in the United States for mobile densification and networking, telecom networks in general. So that had been our focus. In 2018, we merged with a Jersey fiber operator called Cross River Fiber and expanded our footprint throughout northern New Jersey. So we have a pretty robust network throughout New York, northern New Jersey, New York City, northern New Jersey region. And the network in New Jersey started out focused on the traditional backhaul carrier and enterprise carrier, wholesale, and enterprise networks. And we've moved our mobile story from New York City across the river over to northern New Jersey region. And it's been quite successful. We've leveraged that network into quite a few small cells under deployment right now in New Jersey.
Good. Okay, so 5G's all the discussion, all the rage these days. So from your perspective, from the fiber side, how does the fiber playing into the 5G planning efforts or deployment effort we see right now?
That's a great question. And, mobile networks or wireless networks don't work without wires. And with the advancements in densification, they don't work without a lot of wires. So a fiber operator is fiber is an essential part of the mobile ecosystem. So as mobile operators, put antennas and radios literally any and everywhere, every street corner, every subway tunnel, every platform, every floor of every office building, and many, tens of thousands of rooftops. We're in an environment where fiber networks are really critical. And our thesis was that, yes, we need a lot of fiber. And, I've heard the argument that there's a lot of fiber in New York City, for instance, a lot of fiber up Fifth Avenue. The problem is that fiber was built to solve a different problem. And when we entered this business, we wanted to solve the new problem, and that's high capacity. So big cables, 1728 cables, 3456 cables, but they had to be accessible. And imagine the problem that a fiber provider that put a splice point every 2,000 or 3,000 feet would have if they had to put 100 or tens of nodes in between those splice points. They'd be recreating a parallel lateral network all the way up. We developed a new fiber technology to allow us to intercept our large cables, on every single manhole that we traverse. And that's called a front haul access network. We think we're the first in the country actually doing the scale we've done it. We have now thousands of nodes connected to our network just in New York City alone.
Right. So the point you're making is a good one. Is a lot of people think just because there's a fiber running up, as you say, in the middle of Fifth Avenue, therefore you can hang all these small cells, nodes, poles, whatever you want to do off of it. But of course you can't, because you can't actually get to it.
That's right.
It's an architectural problem. So I always think it's like it's a freeway. You build a freeway, you think, great, well now but you can only get on and off at certain off ramps. You can't get off in the middle, even though your house may be down below it or something.
That's actually the perfect visual, right? The backhaul network is the highway,
right?
But the access network is the local road system. If you think of it that way, that is what this architecture looks like. So you take a front haul network and you connect it to edge co-location facilities, and then you backhaul out of the edge co-location facilities back to command and control. So the core, the mobile core, runs out to those edges, and at those edges you do baseband processing and and now there's a lot of other compute that will start happening in those edge facilities. And then you front haul out to the air interface, out to your radio and your antenna.
Yep. So the carriers we talked about a highway. Highway is a shared infrastructure. Carriers in the US, some of them are good at sharing some things. They share towers, probably by necessity. This seems like it's a pretty good opportunity for a shared resource. So how does that work? Does it work?
Well, so that's exactly right. The problem is they need pervasive coverage, right? And the densification that is going to be required with 5G deployments. Initially, they're starting out leveraging macro towers at low bands and mid bands for 5G, but ultimately they're moving down to street level. And to get down to street level, this is no exaggeration. There are 3,300 intersections in Manhattan. All 3,300 need all the carriers antennas at those locations. The problem is they don't have the capital budgets to support single purpose builds to build these pervasive networks. Just like they got out of the tower business because it didn't make sense to build a single purpose tower. It also doesn't make sense to build a single purpose fiber optic network. Like they've gone in cycles where they build some, then they outsource, then they build some, and they go back and forth on this. But in the long run, it's going to be a shared infrastructure. And you can imagine the network, the fiber that we build, the analogy I like to make, it's a horizontal tower business. The front haul fiber, that highly accessible front haul network, high capacity network, is analogous to steel in the air. That is just like a tower. And they've embraced this, and the mobile operators are leasing this front haul fiber, they're leasing pole locations, and they're sharing it because it's the only way to get the capacity across the large coverage areas that they need to do. Right. So they have to. Sharing is the only way to get this done.
Yeah. And I think they realize that if you look at the towers, as you said, obviously towers go to steel in the air, fiber is lying on the ground. They've done that quite successfully. I think they were probably fairly nervous, 20 years ago when they started it or something, but
Sure.
it frees up capital, certainly, right? And
I think that's exactly right. And, you know, sharing today, we're talking about shared physical assets like fiber cables, and we'll put a pole up and multiple carriers on the same pole, and there's sharing there. That's obvious. The next layer, I mean, the sharing today is physical assets. It will eventually be shared spectral assets. I think I see things like CBRS coming down the road, and opportunities for neutral host providers like ZenFi to manage our own radios and share the spectrum and send packet streams back to the applicable operator. I think that spectral sharing is going to be the next shoe to drop. And this is, you know, 5 years ago, we worked on this shared infrastructure. Now it's time to start working on the physical infrastructure. Now it's time to start working on the spectral infrastructure sharing. And CBRS is going to be one of the first forays into this opportunity. We already do it on Wi-Fi with Wi-Fi offload, right? I think we'll do similar things with shared spectral resources as they become available.
Right. Yeah, no, I agree with you. All right, last question. Yeah, and you and I have been on enough panels and things.
I know you're going to ask without hearing it because you've asked it a million times.
So I'll state the question for the audience. What keeps you awake at night from a business point of view? What you know, you painted a pretty good picture here, but what is it that worries you that in, let's say, 12 months' time, if we don't address it today, next few months, it's going to come back and hurt us in 12, 24 months, and we'll think, darn it, we should have done that in the summer of 2020 or something.
Yeah, yeah. So look, you know, there's two big issues. One issue, just general, is the adoption of rules among the municipalities to allow us to do what we need to do to build our networks, right? Yeah. One of the biggest challenges we have is when we go to every single municipality has a different view on you know, what they'll allow us to do. They all want pervasive, high capacity, high speed connectivity everywhere, but nobody wants it in their backyard, or in our case, on the pole in front of their house, right? So this is a continuing battle, and we really need a rule set. And the FCC's, you know, really moving towards this, and the state utility councils are moving towards creating sets of rules for municipalities to adopt. However, this is one of the most challenging processes that we go through. 90% of our work in putting a small cell on a utility pole, you know, on the street, is the planning and getting the approvals and acceptance. 10% is actually doing the work, right? So that's an inordinate amount of time is spent convincing municipalities that we should be able to do it, first of all. And then once they give us blank general approval, we have to go site by site, and it's very cumbersome. It's certainly slowing things down. Right. But I think this will get better over time. But that's if you ask my team what we're working on, most of the time it's working on siting approval.
Yeah, and I hear that a lot. I mean, it's, you know, I think it takes 18 months or something to put a small cell in, and like 17 months it is the planning, the zoning, the permitting, right?
You know, the crazy thing, we could put a node on a pole, you know, completely prepare a pole and put a node on it in just a few days. Yeah. But you're right, we could take 12, 15, 18 months just to get the approval to do that.
Yeah, so good. Well, great. Ray, good talking to you again, as always. That many times. For those who are watching, our interview today has been with Ray LaChance, who is co-founder and CEO of ZenFi Networks. Ray, thanks very much.
Thank you, Ian. Have a great day.
All right. Good.